Well, let's talk about some of the positives and negatives of plasma arc gasification. I mean, some of the concerns, obviously, what's coming out of the smokestacks, are there smokestacks, what's being released into the atmosphere.
Sure.
There was an example a few years ago where they had a fella standing on top of one of the smokestacks and said, you can stand up here for hours and it won't affect you. But
Sure. Yeah, I mean, at the front end, just sort of reiterate that we have selected this system because of its environmental and public health benefits. Sunbay itself is a developer, so we actually have a whole world of technologies to select from. We're not a technology sales group for Europlasma, for example. So it's pretty genuine that we believe this to be the best system, and if it was not, we would stop using it and look at something else. But after a very extensive due diligence that took several years, in fact, we have selected this primarily because of the environmental and public health aspects. The best way, I think, to go about looking at the public health and environmental aspects is to do it in a comparative way. So you want to look at the other ways that waste is being managed and the other ways that power is being produced. Those are the sort of two sectors that we're in. So from a waste perspective, if you compare it to landfills, this waste is being eliminated. It's not accumulating in any way. There are no residuals that are still waste that have to be landfilled. So things like groundwater contamination, a lot of people are now more familiar, but it's sort of a new thing that people are familiar about the air emissions from a landfill. People used to think, well, it's contaminated the soil and the water and that's it. Well, in fact, the decomposition over time releases a lot of methane and other chemicals and CO2 as well into the air. To a limited extent, landfill gas operations do capture that. They did start flaring the gas, many years ago, and now they are capturing that for power, and that's great. I mean, we sort of see ourselves as a complement to that. If you have an existing landfill, you should be doing a landfill gas operation, but we feel you should locate a plasma gasifier also on that landfill for any of the new waste. It doesn't make sense for us to be accumulating these wastes and letting it decompose over 30 and 50 years and even longer, and then deciding to capture the energy that's in it. We should just do that at the front end and avoid all the groundwater contamination and so on. So landfills, I mean, it's fairly clear that even a country like Canada that has lots of land, we also have a lot of water and groundwater that
we also produce per capita the most waste in the industrialized world, and a lot of people aren't even aware of that. I mean, for a country of our size and our small population, I mean, we're producing more garbage than the United States.
Absolutely,
on a per capita basis. So it's time for us to rethink the way we do things, and again, rethink, reduce, reuse, recycle, and what was the one you added there?
Energy recovery.
Energy recovery.
That's the fourth R, exactly, So from a landfill perspective, I mean, it's fairly clear in terms of land use. When you get into the power generation, so the next sort of comparison, you want to look at an incinerator, and that's the big comparison. People want to know why this is different, and we're quite clear that this is not an incinerator and so on. An incinerator, there's a couple of things going on there that are sort of the red flags, let's say, that make this different. The first is an incinerator will create dioxins and furans. Those are what are known as volatile organic compounds, and they're about the nastiest thing, I guess, that would come out of an incinerator in terms of harming public health. They're known to be carcinogenic and so on. And because of the process that we use and other gasifiers use, they simply do not form. It's not chemically or physically possible for dioxins to form in the way that they do with incinerators. So it's not one of these situations where we're sort of creating the problem and have some neat way of managing it. In our system, the problem doesn't even exist. It is not created at the outset. So we're in a much sort of better state. And some of our responses to people say, well, incinerators are getting better about managing things and so on. Well, you're really putting your fate in the hands of the operator to continue operating it properly for 15, 20, 30 years and so on. Of course, filtering technologies are there, but they degrade over time. You have to ensure that they're properly managed and so on. And you know, so that's a concern that I would have as a resident of Ontario when someone says, well, incinerators, you know, we know how to manage the pollutants. So.
Does the gasification process produce a greater amount of energy than incineration?
Yes, that's right. So the other sort of consideration for an incinerator is, well, it's the footprint of it, as well as the ash that's left over. And then you would want to know about how much material is going in for how much power output. So some people compare, say, the cost of a plasma gasifier as compared to an incinerator. And it's probably true that an incinerator can be less expensive for a given amount of waste going through. However, when you compare it to the power output, and now industry has shifted from being waste disposal facilities to power generating facilities because of renewable energy pricing and so on. The amount of power is significantly more. It can be as high as twice as much power from the same output, and certainly a third or more power output from a given amount of waste. So what that means is, you know, when you're looking at actual megawatts put onto the grid, you actually need a smaller facility for a gasifier than an incinerator to get the equivalent power output. If you're driven from waste disposal only, then you could probably do, you know, have a smaller incinerator, but then you have all these other problems and so on with it. So, and I would probably highlight as well this issue about the ash. Incinerators create several types of ash, all of which have to be disposed of. Typically, it becomes a hazardous waste. So when you have municipal solid waste going into an incinerator, municipal solid waste is not a hazardous waste. It's just a waste that could be landfilled. However, when it goes through the system, there are heavy metals in it that come into different concentrations in the ash. And now that ash, which is a very difficult material to handle, normally has to be disposed of as a hazardous waste. Now, some incinerators have had some experience with taking that ash and using it in cement and other things like that. But again, you know, it's really sort of dependent on the feedstock going in and a 15, 20, 30, 50-year sort of horizon.
Well, let's talk about the aggregate from the gasification facility, because there is a byproduct at the end.
That's right. Yeah.
That's what we've got on the screen there for the viewers. It looks like a piece of moon rock or something. Exactly.
Well, it's actually, that is the only physical thing to come out of the plant. That was waste, and it's very similar to obsidian. And what's going on here is the plasma torch vitrifies the physical materials left over. So basically a gasifier in a plasma system sees material as really one of two things. You're either organic or you're inorganic. Organic is sort of broadly defined. It would include plastics and papers and so on. It doesn't mean sort of composting and rotting tomatoes and so on. That's something else. But organics would refers to sort of elemental compounds. If you're organic, you're being turned into the biogas and you're carrying on to power generation. If you're inorganic, so that's the minerals, the glass and metals and so on, you are turning into this slag. And the slag is vitrified, and what that means is sort of locks in in the material, so that there can be no leaching of any sort of heavy metals or anything like that. There was a very extensive study in France, I believe it went on for 7 years or longer, called the Vivaldi program, and it was specifically aimed at showing that Europlasma's slag was not harmful for the public, that it completely vitrified the material, and that it was non-leaching and so on. And we have seen studies that have shown that a Coca-Cola bottle, in fact, is more dangerous, let's say, or it leaches more materials than the slag does. So that's one of the most exciting things about it, is that not only does it not create waste, it actually creates a material that is valuable.
Because it can be used.
It can be used, yeah.
For road surfacing and things of that nature, is that correct?
There's lots of things that can be done with it. it. Probably the simplest is that it could be used as road aggregate. It's very similar to obsidian, so it's a very hard substance. And in fact, it forms similarly to obsidian. Obsidian is a volcanic rock that comes when magma cools and from a volcano. And what we've done here is we've actually created our own magma, lava, let's say, and it's what it looks like as it comes out. It comes out in sort of a molten liquid form, and then it cools into this obsidian-like material. So. Yeah.